Hello students, this video is recorded in order to have a better idea of what these four line graphs are about and relate it to a cardiac cycles happen in your heart. So as what you all know, a cardiac cycle can be divided into two main phases, which are systole and diastole phase. If you want to make the systole more complete or more detailed, systole is represented by isovolumetric contractions and ventricular ejections. Meanwhile, the diastole phases can be divided into three events, which are isovolumetric relaxation. Passive ventricular filling actually is the ventricular filling. Active ventricular filling actually is your atrial contraction or atrial contraction. Okay, so as what you can see, there are four graphs being plotted and shown here, and the parameters are ECG, electrocardiogram, which is measured in millivolt. Okay, pressure indicated by millimeter mercury, and in this graph you shall have three lines being shown here by dotted blue, a firm red black lines, and dotted orangey line. Okay, so the dotted blue line indicating the pressure measured in the left atrium, the black lines indicating the pressure measured in left ventricle, and the dotted orange line indicating the pressure measured in aorta. Alright, so the third parameters will be the left ventricular volume measured in milliliter, and last but not least is the heart sound measured by the stethoscope. Students, as what you all know, a cardiac cycle is generated, okay, with the signals being sent. So definitely ECG is the manipulated variable here that can affect the heart contraction and relaxations. So as what you all know, we shall start with this active ventricular filling, or known as atrial contraction. So during atrial contractions phase, you shall have this P wave generated, where the starting point of the P indicating SA node generates signal, and you shall have this loop down, okay, a falls in the P wave indicating the signal sent through the atrial wall. So after the P wave generated, only you are able to see the pressure increase, okay, in left atrium, shown by this blue dotted line here. So during the atrial contract, definitely the pressure will push the bloods into the left ventricle, and you shall able to measure or see a increment of volume in the left ventricle. So with this increment of the volume in the left ventricle will definitely influence the pressure in the left ventricles. So you shall able to see a constant simultaneous increment in the left atrium and left ventricles after the P wave generated. Right? So after the atria contracted, it will make the maximum volume of blood filling in the left ventricle, and is indicated by end diastolic volume. Okay, so during this atrial contraction, you shall able to see a line between P wave and QRS complex, this indicating the AV node delay the signal for 0.1 second in order for the left atrium to fill the bloods into the left ventricles to reaching EDV value. Okay, so for this graph, the EDV will be around 125 milliliter. Okay, so during this point, you shall able to continue the journey to the next phase, where the at this point here, okay, your AV node relay signal and send to the bundle of his bundle branches, okay, to the apex, show a false here. Then only you have the QRS complex, where the signals are spread to the ventricular wall through these Purkinje fibers. So during this increment, or during this Q to R wave, you shall able to see the pressure start to increase in the left ventricle again from the zero. So during this left ventricle contraction, AV valve will be closed. So this AV valve closed will make a sound being heard or detected, which is your loop sound. Okay, loop sound is heard because of the blood recoiling when the AV valve is closed. Okay, so during this increment of the pressures between 0 to 80 millimeter mercury in left ventricle, the pressure exerted by the left ventricle is not strong enough, allowing the blood forces and push the opening of seminular valve. So during this region from 0 millimeter mercury to 80 millimeter mercury, this is where the isovolumetric contractions happens. Isovolumetric is a closed chamber found in the left ventricles where the seminular valve and the AV valve are closed. Okay, continuously contractions in the left ventricles will reach a certain point which is close to 80 millimeter mercury, and the blood is strong enough to push the opening of seminular valve. With this, the blood will force from the left ventricle, and you can see a starting drops of the blood in the left ventricular volume, and the blood is being pushed to the aorta. So therefore there's an increment of the blood pressure in aorta, following by the drops of the blood volume in the left ventricles. Okay, so when the ventricles reach a pressure around 120 millimeter mercury, another signal will be generated, which is called T wave, indicating ventricular repolarization. This T wave is generated in order to allow the heart to start to relax or diastole. So during this T wave generation, you shall be able to see the pressure drops, okay, in the left ventricles, and until a point close to 100 millimeter mercury, that the blood in the left ventricle is not strong enough, no longer strong enough to deliver from the left ventricle to the aorta. So as a consequence, no more blood able or less blood is flow into the aorta, and this will make the seminular valve close. So during the close of seminular valve, definitely there's another sound being detected, which is your loop sound, where the blood recoiling at the seminular valve. Okay, and of course this is this region where the seminular valve open till the seminular valve close, indicating the ventricular ejection phase. Okay, so during this ventricular ejection, at the end of this ventricular ejection phase, you shall have some blood remaining in the left ventricles, and this value is called ESV, end of systolic volume, so indicated by this graph here, that which is close to 55 milliliter. Alright, so with this information, you are able to measure the stroke volume, which means the volume of blood being ejected per beat. So this one we shall have 125 minus 55, which is around 70 milliliter, indicating the stroke volume. Okay, so we shall continue our journey. Okay, so there will have the ventricle pressure start continuously to drops to 0. So during this phase, the blood is not strong enough, pushing the AV valve to open from left atrium. Therefore, this is a region, okay, from the seminular valve close and waiting for the left ventricle to relax. So this region or this period is called isovolumetric relaxation, and again the left chamber, which means the left ventricle, are a closed chamber. Okay, when the left ventricle pressure is dropped to close to 0 millimeter mercury, of course the blood in the left atrium is strong enough to open the AV valve already. So AV valve will be opened when the left ventricle reaches a pressure close to 0. Okay, so when the pressure close to 0, your AV valve open, definitely the blood from the, if I want to make it more specified, the blood from the lungs flowing into the pulmonary artery and the left atrium will start filling up the left ventricles. And this filling phase is called passive ventricular filling or ventricular filling. Alright, then we shall have another cardiac cycle being generated, which is another P wave. So the duration of this complete complete cardiac cycle takes 0.8 second for a normal healthy person. Okay, which means from the P wave to the end of to the beginning of another P wave, it takes 0.8 seconds. Alright, so I believe I have give you a complete explanation of the cardiac cycle plotted in graphs connecting to the events happen in the left chambers. Hopefully you can get a better or clear idea what is being recorded here. Thank you so much for your attention.